Hello audience, that being Mr. Katamachi, and welcome to the tutorial. And today we are going to be talking about the law. Not that kind of law, I wish, but today we are going to be talking about the law of sines. Now, what is the law of sines, you might ask, considering you have no prior knowledge of the topic. So the law of sines is a little more complicated than basic sines, but once you understand it, it's quite simple. So the law of sines is equal to sine A, which is the sine of angle A, over A side A, sine B, which is the angle B, over the measurement of side B, and then sine C over side C. You can switch the numerators and the denominators as you please, but keep in mind that the law of sines does not work for right triangles. Another thing about the law of sines is that it can only be used if the triangle falls under one of these three categories: angle, side angle, side angle, or angle side. I'm going to show you three example problems, so let's get to those now.
Transition. Alright, so the first of our example problems is this problem right here. Use the law of sines to find B, and this is referring to, of course, side B right here. Now, look, if you look at this triangle, you'll realize that we have angle, side, angle, that being angle, side, angle, and so that the law of sines will be valid for this triangle. So, when we begin solving it, we must first set up the law of sines itself. That being sine A, sine of angle A, over A equals sine B over side B, which equals sine C over side C. So, now that we have this set up, we can start substituting what we already have. So, sine A over 11 equals sine 77 over B. Keep in mind we're trying to solve for B, which equals sine 49 over C. So we can start first by solving for the angle A. Because we have the measurements of angles B and C, all we have to do is add 77 and 49 together. And then when we add those together, we get 126. And so if you know how to solve for any triangle, you would know that you subtract 126 from 180, and you get, as a result, 54. Which means this angle up here will be 54 degrees. So now we can rewrite this by saying sine 54 over 11 equals sine 77 over B equals sine 49 over C. Keep in mind, for this problem, we're only trying to solve for side B, so all we have to do here is simply cross multiply these two. So we solve that by saying B sine 54 equals 11 sine 77. And so since we're trying to solve for B, we divide both sides by sine 54. Ignore that. And when we put that into our calculators, because keep in mind you'll need a calculator for this. Just hold on one second. We get 13.22. Or it's actually 13.24826, etc., but we like to round to the nearest tenth when using this. So side B will equal 13.2. And if this side's 11 and that's a little longer, it looks about right. So we can say that this side is 13.2 units. So let's move on to question number 2. This is asking us to simply solve this triangle. And keep in mind, we have angle, side, angle here. So we can use the law of sines to solve for this triangle. But there's a lot we have to solve here because we have to solve everything, not just a single side, like example number 1. So we set up the law of sines, of course, as we do with every problem. Okay, and so now we substitute, of course, what we have in each problem. This will come out to be sine 57 over A equals sine 109 over B, which will equal sine C over 12. So since we can't really solve for A and B first, we have to solve for C, or for sine C, which we can simply do this by noticing that we have two angles being 109 and 57, and we add the two together, and we get 166. We subtract that from 180, and we get 14. And so we know that angle C is equal to 14 degrees. So now we can put that back in our sine problem, or our law of sines problem being sine 14 over 12. And so now we work our way from the right to the left, which means we can, since we have all these, we can solve for side B. So we write it as follows. B sine 14 equals 12 sine 109. We divide both sides by sine 14 to get B standing by itself. And we get, here, wait 1 second. 46.9. So, it's a little long, but did I mess up again? So we get 46.9 to be side B. Now that might look a little long, but keep in mind that this angle is 14 going to side 12, and since angle 109 is much bigger than angle B is bigger than angle C. So since angle C goes to this side, side B should be much larger than side C. So that's why this is 46.9. So lastly, we have to solve for side A. So we would say that we would cross multiply, of course, and say that sine 46.9 sine 57 is equal to A sine 109. We have to divide both sides by sine 109. And when we do that, you have to use your calculator for this. You will get 41.6 to be sine A, or to be side A, sorry. And once you put that back in, you will have a complete problem, or a completely solved right triangle, I should say. Wait. And so yeah, these are all of your measurements for the triangle, and you have solved that triangle. So then we move to our last problem, which is to solve this triangle right here. Now, for this triangle, we have angle, angle, side, which means that we can use the law of sines to solve for the triangle, being angle, angle, side. So we start by setting up our law of sines as we do with every problem. And so then we write it down here as we always do. This being sine A over A, side A, equals sine 64 over 16, which will equal sine 71 over C. So we start this out by, we can solve for the final angle of the triangle. Now keep in mind, there will be times when you will only have one angle, and yeah, so you might, I can't speak. Just give me a second so I can cut this out. So you'll have to use the law of sines occasionally to solve for two angles, or to solve for one angle, and then you can add the two and subtract from 180 when you have that angle. And so here we add 71 and 64 together, and you get 135. And now you subtract that from 180, and you get 45. So this angle up top is equal to 45 degrees. Angle A is equal to 45 degrees. So now that we have this in, we can solve for side A. Or no, actually, it doesn't matter which order you solve for first, considering we're only solving for two sides. So if you want to solve for side C first, you can do that. But I just recommend going from left to right. So we're going to solve for side A first, which would be A sine 64 is equal to 16 sine 45. So we divide both sides by sine 64. And you get 12.5. Or no, actually 12.58765, which means since it's 5/8, it would round up to be 12.6. So now that we can put 12.6 back into our law of sines, and now we have to solve for side C. So we'd set this up by saying C sine 64 is equal to 16 sine 71. You divide both sides by sine 64. Wait a second. And you would get 16.8 as your final measurement for side C. And so now that we have all of these measurements, we can just put them back into our triangle. And we have solved this right triangle. And so yeah, that is how the law of sines works when you're solving for triangles and solving for the measurements of the triangles, which solving for the triangle means to solve for all of its measurements. But sometimes the problems like question number 1 will ask you to simply solve for one measurement of the triangle, and you'll need the law of sines to do so. And so yeah, that concludes the example problems portion of the video.
So that concludes the video. I'm sorry it's a little long, but as you said in your email, it's fine. And so I just want to quickly thank you for an amazing year in geometry class. I'm going to miss this class very much, and I hope you have a great summer.